right, so today we're going to go over piecewise functions. And so basically just the definition of a piecewise function is a function that behaves differently over different parts of a domain. So basically it's like multiple graphs all on the same graph. So you can see in this picture, I have like 3 different things going on. There's 3 different parts to that graph. So it's just like, but they're all just stuck together. They're just all on the same X and Y axis. So a piecewise function is just like multiple pieces of a graph all put on the same graph, okay? So that's the easiest way to explain that. So when you're looking at equations for that, depending on how many different things your graph is doing, that's how many different equations and domains you're gonna have. So if we look, this equation is gonna be for this graph right here. So the equation for the first piece, and they go from left to right, just like we read, just like we write domains. So this first one would be for like the first piece, the farthest to the left. This would be the middle piece, and then this one would be that last piece, okay? So the first one, it says 4x plus 11. Well, we know 4x plus 11, if you think about just like y equals mx plus b, that would be a line that has a y-intercept up here at 11. So if it kept going, it would cross up at 11, and then it has a slope of 4, which we can see that this does indeed have a slope of 4. So this orange line right here is this equation, 4x plus 11, okay? And then its domain is from -10 is less than or equal to x, which is less than -2. So because I have the less than or equal to, I have a closed circle down here. So when my x is -10 until at -2, I have this orange graph right here. So this chunk of the graph, so from -10 to -2, I'm gonna graph this equation right here. Is everyone with me so far? Okay, so then the middle piece, so from -2 until 2, so this piece in the middle from -2 to 2, I'm going to graph the equation x squared minus 1, which with transformations that we just talked about in the last section, I know that that would just be a quadratic that's just shifted down 1, which is exactly what's right here. So that's a quadratic just shifted down 1, okay? And then the last piece from 2 until 10, I have the graph of x plus 1, which this has a slope like up 1 over 1. I know it counts by 3s, which is kind of an awkward number to count by. But so it has a slope of just 1, and then if I were to keep coming, it would end up crossing my y-axis at +1. Okay, so each equation corresponds to a part of a graph. The domain tells you where to put that graph, okay? So from like -10 to 2, graph this, okay? And the easiest way when we actually will get to graphing these, but so you can just erase parts that you don't need. So if I was to graph 4x plus 11, I would probably graph my y-intercept and then use my slope. And then I would just erase this part that I don't want, because I don't want anything like less than -2, okay? Okay, so then also we can evaluate them. And what that means is you're just plugging the number in and we're like solving for a number. So when it says evaluate the function, all you have to do is you look at your number that you're given and you look at your domains and you figure out the number, which domain that goes in, and then you're gonna put the number into that corresponding equation, okay? So for like x equals 0, which domain do you think it goes in? Is it in between -10 and -2? Is it between -2 and 2? Yeah, so it's in that middle one. So because it's in that domain, I'm then gonna put the 0 into that equation that it goes with. So I would have 0 squared minus 1, which that's just gonna give me -1, okay? So when you evaluate, when you plug x equals 0 in, you would have -1. That would be your coordinate. X is 0, y is -1, which if we look at the graph, when x is 0, y is -1, okay? All right, what about at x equals 6? Which equation do you think I should put it in? Top, middle, or bottom? Bottom, okay? So then if I put it in the bottom one, because it's in my domain from 2 to 10, so if I have 6 plus 1, I'm gonna have 7, okay? And then the last one, -4.5, which one do you think I put that in? The top one. So if I put it up here, I have 4 times negative 4.5 plus 11. What's 4 times negative 4.5? Really hard.
18, negative 18.
Yeah, negative 18, because 4 times negative 4 would be negative 16. And then the 0.5 times 4 would be 2. So we have negative 18 plus 11. What's that going to be? Negative 7. Cool. So then for the last one, we have negative 7. So when it says evaluate, all you have to do is look at your number, figure out which one it goes in, and then put it in the corresponding equation. Everyone okay so far? Okay. So then just a word problem involving piecewise functions. So it says, Alani has a summer job as a lifeguard. So she makes $8 an hour for up to 40 hours each week. So if she works more than 40 hours, she's gonna make time and a half. So she'll make $12 an hour, which we know that's true, like that happens all the time. If you work more than 40 hours, you get like time and a half, so your whole paycheck plus half your paycheck, okay? So we wanna make a graph, a table, and then write a function. So we're gonna write a piecewise function that shows Alani's weekly earnings based on the number of hours she worked. So let's start with the table piece. Okay, so in our table, we have the number of hours she works. So our hours worked. And then we also have how much she's gonna earn, so like her pay. So let's just start with, let's just go by 5s. Let's start with 20. So say she works 20 hours, and we're gonna go count by 5s, and we're gonna go all the way up to 55, because that's gonna help us later. Okay, so if she works 20 hours, how much money do you think she's gonna earn? You guys might wanna grab your graphing calculators, or your phone, or whatever, so that we can calculate. 160. Yeah, because if we take 20 hours times $8 an hour, 2 times 8, 16, 160. So she's gonna make $160 on her paycheck when she works 20 hours. Okay, what about when she works 25? 200. What about when she works 30? 240. What about when she works 35? 280, thank you, Brayden. What about, oops, sorry, those are not in line. 200, 240, 280. Okay, so when she works 40 hours, how much does she make?
3,200.
Yeah, 320. I mean, I wish I made 3,200 every week when I'm here for 40 hours. 3,200, yeah. So okay. So what about 45?
3.
I heard 360. I heard 380. Anybody else have a thought? So if I'm gonna, so I work 40 hours and I make $320 because I'm making $8 an hour. But now for those extra 5 hours, because I'm 5 hours of overtime, so I'm gonna make 5 hours of $12 an hour, right? Because I have more than 40 hours. So 5 times 12 is 60. So I would make 380. Yep, because I make the 320 of $8 an hour. So I have 40 hours where I make $8 an hour. And then I have 5 hours where I make $12 an hour. So if we actually were to calculate that, so I'd have 40 hours that I make $8 an hour, plus 5 hours that I make $12 an hour. And then we said I made 320 plus 60, which would give me the total of 380. Okay. All right, what about 50 hours? What do you guys think for that one? 440. How'd you get that?
Added 60.
Added 60. Okay. Because yeah, so now this time, instead of just 5 hours of overtime, I would have 10 hours of overtime. So I still just have my base of 40 hours that I make $8 an hour, but now I have $10 where I make $12 an hour, or 10 hours where I make $12 an hour, which would be 120, and so then that would be a 440. Is everyone okay with this, or yeah? And then for the last one, what would I have for 55? 500, yep. Okay, so here's my table. This is how much I make every week when I'm working. Now, it does say I need to graph it, and then we're gonna write a function. So, okay, so if I try to graph all these points, I'm gonna come up to 500, and then my hours worked we'll do as my x's. So I'm just gonna jump. Here I am at 20, and 30, 40, 50, 60. And so I'm just plotting these points, okay? And then I'm just gonna count by hundreds over here. So 400, 500. Okay, so when I'm at 20, I'm at 160, so I can just kind of right in the middle. When I'm at 30, I'm at 240. So again, kind of right in the middle. 40, I was at 320. So like right here. 50, I'm at 440. So up here, and then at, let's do 60 just for good measure. If I were to work 60 hours, how much money would I make?
560.
560. Okay, so then I have another point to plot. That one's gonna be like all the way up there. Okay, so I can connect these. And then this one will be really high and be all the way up there. Okay? My graphs aren't perfect, guys, but close enough. But we can see on our graph that it's kind of straightish. It should be straight. It's a linear function. So I'm making the same amount of money. So this is straight, but then after I get to 40 hours, it gets way steeper because now all of a sudden I'm making like time and a half, okay? So if you think like my slope is 8 because I'm making $8 an hour, so this is a slope of 8, but now all of a sudden over here, I'm at a slope of 12, okay? So not perfect, but yeah. Okay, so now to write a function of this, I know I have two different parts of my graph. So this part right here, so from here to here, like this stuff right here where I have the less slope, and then from here to here where it's steeper. Okay, so I have two different pieces of my graph. So in order to get ready to write my function, I would say f of x, because it's a function, and then you can just do one of those brackets. And I'm trying to write two equations and two different domains. Okay, so that's now what I need to go ahead and fill in. Okay, so let's start with the domains. I think that's easier than starting with the equations. For the first one, so from like 0 to 40 hours, I make $8 an hour, correct? So what do you think my domain for that would be, for the first part of the graph?
0 to 40.
Yeah, 0 to 40, because on my x's, I'm going from 0 to 40. So that's one piece of the graph. So I could say, if you want to write it, you can write it like 0 is less than or equal to x, which is less than or equal to 40. Or you can write it the way we did on our posters. You can go from 0 to 40, just like that. Either one, okay? And then what do you think the other domain would be?
40 to infinity.
Yeah, 40 to infinity. So even though there's only a certain amount of hours in a week, we can just pretend that we can go to infinity, okay? So we can go 40 to infinity, okay? So there's our domains. Now we need to actually figure out our equation. So what do we think we can figure out for this first equation? So it's a straight line, right? So let's think y equals mx plus b. So if I work 0 hours, do I get any money? No. So where do you think my y-intercept is going to be?
0.
Yeah, 0, because it would be at 0. So I know it's going to be plus 0, whatever that is. And then what do you think my slope is? Katie?
8.
Yeah, 8, because I'm making $8 an hour. So I would say 8x, and I really don't need that plus 0. That just kind of helps me with my graph. So my first equation would just be 8x, okay, because I make $8 per hour. The x is my hours, and then from 0 to $40. Okay, and then the last one, now I need to figure out this equation. And this one's just a little bit trickier. So, anyone have any thoughts for how I could approach this? It's okay if you don't have any thoughts. Okay, so let's think about it. So we make $8 an hour for 40 hours, right? And then over 40 hours, I make $12 an hour. Okay, so if I want to break this up, so we knew every time I was always making that $320 as my base amount, because no matter what I work, so if I work over 40, I automatically get $320 of the $8 an hour. Is everyone okay with that? Okay, so I automatically always am going to have $320. Okay, and then I know I'm going to get $12 an hour for everything over that 40 hours. So this comes from, this is my money from 40 hours. Okay, so when the money I make from 40 hours, I get $320. Then everything over 40, I'm gonna get $12 an hour. But I can't just say X, because my X is for my hours, because then that would be for all of them, right? So I want to do instead, I want to say X minus 40. Okay, so say I were to plug in like 55. So if I plug 55 in over here, so 12 times 55 minus 40, well, 55 minus 40 is going to be 15. So I'd have 12 times 15, so I'd have 15 hours of overtime where I make the $12 an hour, plus my $8 an hour that gave me the $320. Does everyone see that? Okay, so I get, yeah, so here's gonna be my equation. So I can go ahead and just simplify this. So if I have 320 plus 12x minus 40, I can go ahead and just distribute. So if I distribute 12 times x, what would I have? 12x. And then if I distribute 12 times negative 40, what would I have? 440. 480, yeah. So I'd have negative 480. Okay, and then up here I have the 320. Can I combine some like terms? What would I have?
Plus 3 or 12 minus
160. Yeah. Yep. Okay. So this is going to be our simplified equation that I would then put over here, because if I was graphing it, which I did, so it has a slope of 12, and then this steep line, it would actually come down and cross at like negative 160. So that's why it's important to simplify it, because when you're graphing it, if I asked you to graph something like this, we wouldn't know how to graph that, would we? Like something like this top equation. So we need to simplify it so that we can put it into our piecewise function. So I would have the 12x minus 160, okay? So that's this line right here. And if it kept going, it would cross down here. My y-intercept would be negative 160, okay? But the equation where we got it from is from like talking about the money and just having to subtract out those 40 hours, okay? Is everyone okay? Confused? Questions? Okay. All right, so then it says, how much will Alani earn if she works 37 hours or 43 hours? So let's go ahead and let's just plug it right into our equation. If she's gonna work 37 hours, do you think it goes in the top equation or the bottom equation? Top. So if I plug that into the top one, I just have 8 times 37, which what is that gonna give me? Those of you with your calculators out. 296, yeah. So I'm gonna make $296 when I work 37 hours. Okay, for 43 hours, do you think I put that in the top or the bottom equation? Bottom, okay. So if I plug that in, I'd have 12 times 43 minus the 160. 12 times 43, what does that give me? 396. Minus the 160, what does that give me? 236. 236? I got 350. Is 12 times 43 really?
560.
Yeah.
Ah, I was close.
I was like, wait. 516. So then what should we have?
And then it's 356.
Yeah, it's gonna be 356. So when I work 43 hours, I make $356. Okay, so just being able to now like take what we know, make tables, graphs, write equations, so all of that goes along with piecewise functions. Okay, so then let's go ahead, let's just graph one. So this time we have the equation, so we don't have points to help us with our graph. We just have the equation. Okay, so my equation is just, so we have f of x is equal to, so it has three pieces. -4 when x is less than or equal to -2. We have x minus 2 when we're from -2 is less than x, which is less than +2, and -2x plus 4 when x is greater than or equal to 2. Okay, so if I were to graph this, okay, so the first piece at negative, it's just -4. What's that line gonna look like? Just straight? Yeah, because there's no x, so it's just gonna be a straight line down at -4. It's just gonna be a horizontal line. So I can come down here to -4. And then where should I start this line in terms of my domain? If it says x is less than or equal to -2. Faith, what do you think? Okay, so if I start at -2, should I go left or should I go right for my line? Right, so if x is less than -2, is it gonna be the numbers less than or greater? Yep, perfect, so we're gonna do a less than. And then do you think I should have an open or a closed circle? Closed, yep, because it has the equal to. So here I am, I have a closed circle, and I can just draw a line like that, okay? Because it's gonna go on to infinity. So it's x is less than or equal to -2. So because it's the less than or equal to, I should have the closed circle, and then it starts at -2 and it's all the numbers less than -2. Everyone okay with this first piece? Okay. All right, next one. So I'm doing x minus 2. How would I graph something like this? Paige, where do you think my y-intercept is? -2. So I can go ahead and plot a point right there. And then, Paige, what's my slope? So if I just have x minus 2, so my slope on my x would be 1. Yeah, just 1. So I can go ahead and I can graph this. So when I have a slope of 1, I can go up 1 over 1, up 1 over 1. In the opposite direction, I can go over 1, down 1, over 1, down 1, and then that joins up with this point I have right there. Okay, should I keep going in, so here I am, 1, 2, 3. Should I keep going up farther? What do you guys think? If I look at my domain, it's from -2 to 2. So can I keep going at like 3 and 4? No, so I don't need those, I can erase them.
Can't you only go to 2 since it's not less than and equal to?
Exactly. So if it's less than and less than, should I have open or closed circles? Open. So this one's gonna be an open circle. This one right here, because it joined up with a closed point, I can leave it as a closed circle, okay? Because this point, it fell right on top of itself. Because from the first graph, I had a closed point, but now from this second equation, it would be open. But like open on top of closed is gonna be closed, okay? So you can just leave it closed. But so here I have my graph in here. So here's the middle piece. And it can only go from -2 to 2. I can't keep going down and I can't keep going up. It can only be in this domain right here. Okay, and then the last one I have -2x plus 4. And it says it's in the domain of x is greater than or equal to 2. So if x is greater than or equal to 2, I know that it's gonna be this part of the graph, right? So it's 2 and the number is greater than 2. So all of this over here. But in order for me to graph something like this, I need to use this y-intercept and my slope, and then I can just erase this stuff I don't need, okay? So then Haley, where's my y-intercept gonna be?
4.
4. And then what was my slope?
-2.
Yeah, so I have a point up at 4, and then my slope of -2, so I can go over 1, down 2, over 1, down 2. So here it is, it goes right on this same point right here. And because it's x is greater than or equal to, I can now fill in that point that was open before, okay? Because it fell right on top of it. Okay, and then I can keep going, so over 1, down 2, over 1, down 2, keep going. Okay, so should I draw this whole line right here? Everything? No, I only want to be in my domain, so I don't want these ones. I only want this part right here. Okay, and then because it can keep going, so x is greater than or equal to 2, my x can keep going to infinity, so I want to put an arrow on the end. Okay, so here's our piecewise function. How do you guys feel? I feel like these are the worst things ever, because my trig kids hate them, so they like, because we were recently doing them, and they were like, oh, we need these from last year, so if you hate them, it's okay. But I don't think they're the worst thing ever. Okay, so then let's go the opposite way. So this time I have an equation and I want to write the rule or I have a graph, sorry, and I'm trying to write the equation. Okay, so kind of just my steps for that. So it says determine how many different segments there are. So in this graph I have one piece here, one piece here, and one piece here. So I have 3 different segments of my graph. So then what I would want to do is I need to find my domains for each segment and then just write my equation for each segment, okay? So I have 3 pieces, so I can say f of x is equal to, and then I'm going to have 3 equations and 3 domains. Okay, so let's go ahead, let's just start with our domains. So we're counting by 2's on this picture. So middles would be 1. So Mackenzie, what do you think my domain of this blue segment would be? You're good so far. Yep, less than, and then what number would I be at right here? Yeah, 1. Yeah. Yep, so which is less than 1. Okay? And if you get confused with those symbols, remember guys, we can write them like this, -2 to 1. I would just have to make sure I do my brackets and parentheses correctly. So because I'm filled in, I would have a bracket or the equal to, and then because I'm not filled in on the other side, I'd have the parenthesis. Okay, so either one of those is fine. Okay, so you can always say like -2 to 1. Okay? Also, one thing I'll say real quick, so graphs, piecewise graphs don't always have to touch each other. Like in that example, they all joined up and it was all like one line. But over here, you can see that I have like a gap. That's totally fine. Okay? All right, so then Cooper, what do you think for my orange function for my domain? What would that one be?
For which one?
For the orange, or red, I don't know, this one. Where do I start at for my x's?
Like 5.
So since I'm counting by twos, it'd actually be 1, so that's what's tricky. And then where would it end?
5.
Yeah, so I'm going from 1 to 5. Do I want brackets or parentheses?
Brackets.
Brackets, because they're filled in. So I'd have 1 to 5. Okay. And one thing, you can't ever have like 2 filled in points. This one couldn't be filled in and that one be filled in, because then it wouldn't be a function, okay? So you can see that on one of the numbers, I have a parenthesis, and on that same number, I have a bracket, okay? Because they both can't be filled in, okay? And then, Kaden, what about my last one? Where do you think my domain for the green is gonna be?
4 to 8.
4 to 8. I think it's gonna be 5. I think it starts right underneath this orange point. But yeah, so from 5 to 8. And then, do I want brackets or parentheses? Brackets. Do I want a bracket on the 5? Well, technically the orange one's on top of it, so then it would be a parenthesis, it'd probably be open, but it's okay. So we'll throw a parenthesis on that one, okay? Because we can't have multiple numbers with the same, like, we can't have brackets on both. So it would be a parenthesis because it's underneath, okay? Okay guys, so we'll figure out the equations tomorrow, and then I just have like another slide left. But tomorrow we'll just have work time, and then I'll give you your note card for the quiz on Monday. But otherwise, you guys are good. Make sure if you didn't finish your IXL, to try to finish that up, because I'll look at it probably by C day, okay? Oh, thank you. Alright, for those of you guys at home, how did everything go? Were you guys able to see the PowerPoint at home, like follow along and everything? Or any questions? No? Okay, well then you guys are just good to go. Alright, thanks guys. Bye.
Why should it be an open and closed circle? I don't think.
For the last one?
No, for any of them. Why are they like open to closed?